Welcome to my YouTube channel, Bite-Size Data Consulting. So we are trying to give you an introduction to big data. All right. So we are calling this series of lectures as bite-sized big data because big data is the theme that we are trying to handle here in bite-sized videos. Three ways how we are different. We only teach you what you need, not what we know. So basically the idea is to give you only the information that you would require, not all the theory that is required that you can find anywhere else on any other type of videos. We let the machines do what they do the best. So basically there are a lot of under the hood details which you will never need in your life. So we'll not teach you all that. We just leave it to the machines to handle that. We just teach you enough so that you can bite, chew and digest everything you learn. So the idea is that we teach you only what you need exactly, just enough, so that you can bite, chew and digest. And one more thing that you should keep in mind is we don't teach you any theory which you'll never require. So just pay attention to whatever we are saying. This is just enough, not more and not less. One last thing I want to emphasize here is each video will be 10 minutes long so that you can bite, chew and digest everything you learn. And if at all you want to revise, you can come back and do it in another 10 minutes. All right. So let's get to business. All right. Let's get started with a small problem. The first statement is you want to understand what are the kind of problems that big data can solve. For that, let's start with a small problem and see why do we need big data in the first place. All right. So imagine I have a small data set here which actually has got three columns as you can see here, which is movie name, release year and the total collection. So here I'm just trying to calculate, as you can see, what is the total collection per year and what is the average collection per year. So the total collection to 2017 would be 2000 plus 4000, that is $6,000, and the average is going to be 6000 by 2, that is $3,000. So if you want to do it, please pause the video and do the math for the remaining years. All right, so I've done it for you and I can this is the answers that you will get. All right, so let's further complicate this question a little more and try to do the same thing for this data set. So as you can see, you have around 26 records. You can still do it. Basically it's a little tough. You can pause it and do it. Maybe it will take you a little a minute or two more than what it took before. So for 2017 you have 6000 here, and another set we have 12,000, another set you have 18,000, and it goes on. So what I've done is I've done it for you and I've stored the answers for you. But the thing is, the major point that you should keep in mind is you can still do it, but you might need some help like Excel sheet or a calculator to do it. All right. Now imagine you want to do the same thing on all the movies that are released in English in the last 150 years. So somebody wants to identify what are the years where you had maximum number of collection in the last 150 years. Okay. So for that I've gone to the IMDb database. I mean, this is an internet movie database. It's a very famous one. So they say that these are the number of titles that were released in the last 150 years, you know, roughly. Could be accurate, could not be accurate, but this is the number. So what we can see is now just like earlier problem, if you want to put everything into an Excel sheet, it is not possible because that is the maximum limit that we have in an Excel sheet. Okay, so you can see that the maximum limit in an Excel sheet is way less than the number of movies that are released in the last 150 years. Okay, so that means you cannot do it. So you cannot do it in an Excel sheet. So it makes sense, right? So what do you do next? So that's where the databases have come into picture. So for those of you who do not know what is a database is, so database can be considered as a very big Excel sheet. So it almost has the same structure. This is something, this thing that you see here, this could be called as a database table. Okay, so it will have its columns and names which are columns, and rows which is data. Okay, so that is called as a database. Okay, so I want to do with a huge thing, so database. Okay, you might use database, right? So now let's get a little further and do something similar with the Twitter data. Okay, so now consider this question: how many people tweeted about a movie called Batman in the last 24 hours? So all of us know what Twitter is, right? Let me tell you what. Let me explain you this question. So basically, imagine these are the kind of tweets that people do. So imagine ABC is a guy and he has tweeted, "I like Batman." So we are just trying to understand how many people have tweeted on the movie called Batman. Okay, so Imagine only 4 people have tweeted in the last 24 hours. So the answer will be 4. It sounds very straightforward. But the point that you have to understand is to come to this answer, which is a very trivial answer, like how many people tweeted about Batman in the last 24 hours, you know the number of tweets that you have to scan. So that comes to be 15 million, 500 million. So you can see that 500 million is this big number. I'm just giving you the number so that you understand the complexity that we're talking about. But to come to this number, do you know how many tweets we must scan? That is 500 million. Okay. So 500 million for the last 24 hours. Okay. So if I want to do a same math for the last 1 month, so this is the number that is going to come. So I think I've made my point very clear. I don't want to go any further. So basically, so the point is, even to get the most basic information, you must scan a lot of data, right? All right. So we all of us understand that to get a basic information, you have to scan a lot of data. So this happens to be the first characteristic of big data, which is volume. All right. So just because you have volume doesn't mean it's a big data problem, but this is the first characteristic you will be considering to call that problem as a big data problem, which is volume. Okay. So now let's get into the next question. Now the answer for this question can change almost every hour, every minute, and every second. So let me just help you understand this. 24 hours could be like 12 in today, 12:01 till 11:59 in the night, or it could be like 11 a.m. yesterday to 11 a.m. today. It could be anything. So this is a moving target. So this Twitter data will be published every second, every minute, and every hour. So basically the velocity with which the data is getting published is very high. So this is the second characteristic that you should keep in mind. So we know that we have volume. Second is we have velocity. All right. So now imagine if the producer knows that what people are talking about the movie, he can take some action like create a new trailer, increase advertisement, etc. So the point here is there is some value that a producer is deriving out of this analysis, right? So obviously volume is the most important thing. Second thing is the velocity at which the data is getting updated, and the third thing is value. Some business value has to be derived out of everything that is being done, right? So imagine if I want to see those people who have tweeted also rated the movie badly in IMDb. Imagine a person has written that I hate Batman, and he went to IMDb and have given 1 star there. That's what I'm trying to see. But you as you can see, Twitter is a different data, and IMDb is a different data. So basically we have variety of data that you can join and come to some conclusion. So now the new factor that has come into play is the variety. So as you know, the volume is there, velocity is there, value is there, and variety is there, right? So basically and one more thing that you have to keep in mind is whatever you are doing till now, right? So this is what is called as big data analytics, even though the questions sound simple enough. So these are the type of questions that somebody is solving when they say we are doing big data analytics. So tomorrow if somebody is throwing a word called big data analytics, you can quickly relate to whatever you just understood till now. All right. Now, any problem that involves volume, velocity, variety, and has some real business value can be considered as a big data problem. So this is these are the kind of problems that we are trying to, solve. All right. So remember this definition: volume, velocity, variety, and value. So these are the 4 V's of a big data problem. All right. So congratulations, you have successfully understood what are big data problems basically, and that's all I had for this video. And if you want to know how these problems are solved, keep watching my channel, and I'll post another video which actually solves the problems that we have discussed till now. Thank you. Welcome to my YouTube channel.